This question comes from an email by Sophia, who asks, my daughter loves her spinning top. It always falls over after a minute. But what if you had a top that was perfectly balanced, and nothing could slow it down? What would happen if it just kept spinning, faster and faster? A normal top stops for two reasons: friction from the surface it's spinning on, and air resistance. To get our top spinning forever, we need to solve those problems. Let's imagine it's made of a frictionless material and we place it in a perfect vacuum chamber inside the playroom. Now, nothing is slowing it down. It would, in theory, spin forever at its initial speed. But Sophia's question is more interesting. What if it kept accelerating? Let's say our top accelerates by 1 rotation per second every second. For a while, not much happens. But soon, the edges of the top are moving incredibly fast. A standard top is about 3 centimeters from its center to its edge. After about 90 minutes of acceleration, that edge would break the sound barrier. Even in a near-perfect vacuum, there are still stray atoms. Smacking into them at supersonic speeds would heat the top surface, causing it to glow. But we're about to run into a much bigger problem. The forces on our spinning top would be immense. Any normal material, wood, steel, even carbon fiber, would be torn apart by the centrifugal force long before it reached any interesting speeds. To continue, we have to assume our top is made of a hypothetical material with infinite tensile strength. It cannot break. Now, what if we tried more power? As the top spins faster and faster, approaching the speed of light, something strange begins to happen. Thanks to Einstein's theory of relativity, its relativistic mass starts to increase. At first, the change is tiny, but as it gets closer to the light speed limit, its mass skyrockets. Within a few hours, your daughter's toy top, once light enough to hold in her hand, now weighs as much as a car. A few minutes later, it weighs more than the house. The floor can't support it. But it won't just crash into the basement. It's about to do something much, much worse. When the top's mass becomes so great that it is contained within its own Schwarzschild radius, it collapses under its own gravity. It becomes a black hole. In the final moments, the intense gravitational pull would rip the very atoms of the house apart. The light from the collapse would sterilize the continent just before the black hole began to swallow the Earth itself. It turns out, giving your child a toy that defies the laws of physics is a bad idea. On the bright side, that playroom is now a permanent navigational hazard for all future interstellar traffic, which is, in its own way, a kind of legacy.